Hello everyone, I want to talk to you about the product rule and the quotient rule. I'll start off with the product rule. So if you have k of x, which I'll just generally call k later on, is equal to f of x times g of x. So function times its function, that's what product means, multiplication. Then if you want to take your derivative, you'll notice that this is like two kids playing Monopoly. One kid takes a turn. So we take the derivative of the f, and the other kid is just going to sit back and watch. Right? Both of the kids can't take a turn at the same time at Monopoly. And then you're going to add to that. Now the first kid is going to sit back and watch while the second kid takes a turn. Right? That's the product rule when you have two functions multiplied by each other. So I'm going to take a look at your homework, and this is going to be on page 3 of your homework assignment. And it reads as such. You guys have that f of x is equal to 4x cubed e to the 4x minus 1. Okay, so you can put parentheses here and you should be able to see that you have two functions that are being multiplied by each other. 4x cubed times e to the 4x minus 1. So if we want to take the derivative, then all we're going to do is we're going to take turns. So take the derivative of this first one, which is 12x cubed. I'm going to underline that because you did take a derivative. Now you're going to leave the second one alone, e to the 4x minus 1. And then you'll add to that. The first one is now going to sit back and watch. So you have 4x cubed. And now you're going to take the derivative of this e term. Okay, so let me open this so that you can see all of that. So that's going to be copy e to the 4x minus 1 times the derivative of this power that we didn't touch, which is 4. Like that. Okay. So there's all the pieces. Of course, you can simplify that if you so desire. Then f prime of x equals 12x cubed e to the 4x minus 1 plus 16x cubed e to the 4x minus 1. Okay? So what some people do is they like to factor things out. That's perfectly legitimate. I usually separate it into two pieces. And my wall occurs when there's a sum. You'll notice there's a sum right there, right? So that's what tells me this piece is separate from that piece. So I have to ask myself, what can I factor out of box number 1 that I can factor out of box number 2? What do they have in common? So here, f prime of x then equals 4 is the biggest number that's in common between 12 and 16. This one has 3 x's in it. And this one, oops, I made a mistake. Let me go back and clean this up because I definitely don't want to mislead you. This is 12x squared, right? Right, from bringing the 3 down, multiplied by 4 and subtracting 1. So we have x squared that's in common in both boxes, and then you can see in both boxes e to the 4x minus 1. So if I do that, then I should be able to ask myself, what's the leftover in box number 1? So if I take box number 1 and I divide it by all of these pieces, 12 divided by 4, the x squared divided by x squared, that divided by that, I should simply be left with a 3. And then here in box number 2, divide that by the 4x squared e to the 4x minus 1, then I get a 4 and I get an x there. Alright, so that's another version of your answer. Alright, I want to look at number 3 in your homework assignment also. Okay, these are problems that it would be a great idea if you were to try them yourself after you've seen this. So for problem number 3, you're given f of x equals 3x cubed natural log of x to the 6th power. Notice you should be able to put big parentheses there, and you can see that you have something with an x in it times something with an x in it, so it should be the product rule. So then your f prime of x, again, you're taking turns taking the derivative, so 9x squared is the derivative of this first piece. We're going to leave this natural log of x to the 6th alone, plus, now we'll leave the 3x cubed alone, and now we'll get it taking the derivative of the natural log of x to the 6th. What is that? 1 over whatever's right after the natural log, which is x to the 6th power. Notice we just dropped that x to the 6th to the denominator, so we have to take the derivative in order to finish this off, like that. Okay, so that's all the pieces of that. Alright, so of course you can simplify that. F prime of x then equals 9x squared, the natural log of x to the 6th, plus, let's put this over 1, put this over 1. Again, there is a wall right here, but this should combine for one chunk of information. So you get 18x to the 8th, and down here you get x to the 6th power. Alright, so we're almost there. So then f prime of x then equals 9x squared natural log of x to the 6th plus 18x squared. Okay, of course you could factor out a 9 and an x squared out of both of those pieces. That would be perfectly legitimate also. Okay, so there are other examples of the product rule, namely problems 8 and 10 are product rule also. But I'm going to shift gears now and talk about the quotient rule, which is another one that you guys are going to be responsible for. Alright, so let's start off with the quintessential quotient rule, which is problem number 2. Please note that all of these problems have been worked out in their entirety on page 4 of your notes, so please use that as a resource. Alright, so let's see, problem number 2. So if you're looking quotient rule, okay, your quotient rule says if you have k of x equals f of x divided by g of x, right? A quotient, something divided by something else. So then k prime equals low d high, this is how I learned it, minus the high, let me open this up, d low, all over the low squared. Okay, so